What's up, everyone? Welcome to this video. In this episode, I'm going to be solving the math portion of the SAT exam that was administered in 2017 of April. So in this video, I'll probably do section 3, which is the no calculated portion. I'll be doing all of them. All right, so I believe the solutions are online, like the worked out solutions. In the document I found, I only had the answer key. But I'm sure since they had a review session of this exam, I'm sure the fully worked out solutions are online somewhere that you could probably find. If you're not able to find it, then hopefully my explanations can be helpful to you. Or if the explanations there weren't helpful, hopefully this video can be of help to you. And of course, if you have not solved these problems before, I recommend you do it first before watching me solve it. Okay? So you can just find the exam online, or you can just pause the video right before I solve it, and you can give it an attempt first. And of course, time yourself to see how long you take. Okay, of course, I'm not going to be timing myself here since I'm going to go a little slower to explain my thought process and write things down. All right, so without further ado, let's begin. So number 1 says a farmer sold 108 pounds of produce that consisted of Z pounds of zucchini and C pounds of cucumbers. The farmer sold the zucchini for $1.69 per pound and the cucumbers for 99 cents per pound, and collected a total of $150.32. Which of the following systems of equations can be used to find the number of pounds of zucchini that were sold? Okay, so what is a system of equations? You have a certain amount of variables that are involved, and you have a equivalent amount of equations. So for example, in this case, there's 2 equations for 2 unknowns. You need to have the same number of equations as variables in order to be able to possibly be able to solve it. If it's a linear system, totally doable. Non-linear system, much harder. All right, but anyway, so it says the farmer sold 108 pounds of both zucchini and cucumbers. So if Z is the number of pounds of zucchini and C is the number of pounds of cucumbers, then Z plus C is 108. 108 pounds total. Z of them were zucchini, C of them were for cucumber. So we can eliminate A and D right away. Only B and C have that. Now, as for the price, for each pound of zucchini, he sold it for $1.69. So it'll be $1.69 times Z. This is price per pound times pounds. So the pounds would cancel. You're left with the dollars. And then similarly, 99 cents per pound for a cucumber. And then he made a total of $150.32. Okay? And which one is that? That is choice B. Okay? Pretty easy, in my opinion. The formula above gives the monthly cost, C, in dollars of operating a delivery truck when the driver works a total of X hours and when Y gallons of gasoline are used. If, in a particular month, it costs no more than $2,000 to operate the truck and at least 150 gallons of gas were used, what is the maximum number of hours the driver could have worked? So the problem with a lot of these problems is there's lots of words. And you got to filter through them. Some information might be irrelevant. And then you got to pick out some of the keywords. So the keywords I already picked out were no more than, at least. That signals to me that I should probably set up an inequality. So the cost was no more than $2,000. This is the cost equation. So 10x plus 4y, that's the cost. No more than, which inequality sign is that? Less than or equal to. Okay? And at least 150 gallons of gas to use. So Y is the gallons of gas. Y at least greater than or equal to 150. All right. So if I rewrite this first inequality as Y less than or equal to 2,000 minus 10x over 4, I just isolated the Y. Notice Y is less than this guy. Y is greater than this guy. So I could write it as one big inequality. This is like an AND condition. Like this. Okay, so I on the test would not have written this, but I'm showing you my work. So in the interest of time, of course, be careful if you're skipping steps. If you're very confident, then go for it. If you're not very confident, just take the extra time to write out your steps. Of course, there's a trade-off right there. If you show more steps, Even though this is multiple choice, if you show more steps, it's only for your own benefit, but it costs more time. So you might need the extra time for additional problems. But anyway, y is between this and this. So what if I just get rid of the middle? So 150 less than or equal to 2000 minus 10x over 4. And now what have I solved for x there? So 150 times 4, that is what, 600? Okay, less than or equal to 2000 minus 10x. Solve for x, so 10x is less than or equal to 1400. X is less than or equal to 140. Okay, and that's the answer, B. The maximum number of hours is x maximum, so less than or equal to 140, right there. Okay? Which of the following polynomials is equivalent to the expression above? So this is just testing basic algebra of and the distributive property. So let's distribute the minus 3, so minus 3 plus 3x. Distribute the negative 2x, so it'll be negative 2x squared minus 10x. Okay, combine like terms. So usually I put a dot or underline underneath to signal that I already combined them. 5x squared minus 2x squared, that is 3x squared. Plus 3x minus 10x, that's minus 7x. You still have a minus 3. The answer is A. Which of the following lists all solutions to the quadratic equation above? Okay, so there's a very quick way to do this. You could just plug in these values to see if you get 8. So for example, if x is 8, you get 8 times 10. That's clearly not 8, that's 80. Eliminate. If x is 4, you get 4 times 6. That's not 8. Eliminate. If x is negative 4, you get negative 4 times negative 2, which is 8. Good. How about 2? 2 times 4, that's 8. Keep that. Root 6, clearly that's not going to work. Eliminate. Answer is C. You could do it like that. Or you could properly do it. See, this is a trade-off again. You could have just went by the choices and got the answer. Or you could just use the quadratic formula or factor. So you have to move everything to one side. So if I distribute this x, it'll be x squared plus 2x. Let me move this 8 to the other side also. Minus 8 equals 0 then. You can factor. This will be x plus 4. X minus 2 is 0. X is negative 4 and 2. Same answer. Not surprising. Okay, so you can either go by the choices. So to me, if I just quickly do it in my head, I would have picked C in a matter of maybe, like, if I give 1 second for each choice, matter of 3 seconds then. 4 seconds if I really check all. This one, not too bad either. Took me less than 15 seconds, right? Or however long I wrote it. So not too long either, but again, whatever you're comfortable with. Okay. Next, in the figure above, BC and AD are parallel. AB and EC are parallel. CD equals CE, and the measure of ABC is 115. What is the measure of BCD? Okay, so it's saying these are parallel. These are parallel. And then this is congruent with this. Okay? So, and we're asked for BCD, this angle up here. Okay, so we need to find this angle here and this angle here probably. I know that this is a parallelogram because these are parallel and these are parallel. So this angle and this angle must be supplementary, meaning this angle plus this angle equals 180. So this angle is 180 minus 115. And what is that? That's 65 degrees. Okay? I also know that this one is 65 degrees. How do I know that? Well, this line and this line are parallel. These are alternate interior angles. Okay? And I also know this guy is 65 degrees. How do I know that? Well, this is an isosceles triangle because these two sides are congruent. So these angles must be congruent as well. So if this is 65, this is also 65. Now this angle, how do we find that? Well, the sum of the angles inside the triangle must be 180. So this is 65 plus 65 is 130. So this must be 180 minus 130, which is 50 degrees. And now 65 plus 150, that's our BCD. What is that? That's 115 degrees. At a store, a coat originally priced at P dollars is on sale for T dollars, and the relationship between P and T is given in the equation above. What is P in terms of T? Oh, this is very easy. You just solve for P. So P is T over 0.8 D. And you're done with that. I don't know why they asked that. That was way too easy. Okay. The solution to the system of equations above is x comma y. What is the value of x? So to solve for systems of equations, you can use substitution or you can use linear combinations. So I'm going to use linear combinations here. Equation 2, I'm going to multiply by 2 on both sides. So I would get x minus 2y is 20. Okay, I'm going to add it to the first equation. So I'm going to bring it right there. Add the two sides. You would get 2x on this side. Okay, the minus 2y plus 2y would cancel. X plus x is 2x. And then you get 20 plus 16, which is 36. So x is 18. Answer C. Which of the following is the graph of the equation y equals 2x plus 3 in the xy plane? So right away, I can eliminate C. How do I know that? Well, this is the slope. Slope is 2. It's a positive slope. This is a negative slope here. Okay, so that's why I eliminated it right away. Okay, the y-intercept is 3. It looks like all of them have a y-intercept of 3, so that doesn't really help us to eliminate anything. So we got to go by the slope now. So if I go from the y-intercept up to right 1, because slope is rise over 1, so rise over run, so up to right 1. That works. How about here? Up to right 1, not quite, a little short. Up to right 1, way off. So answer is A. The system of equations above is graphed in the xy plane. Which of the following is the y-coordinate of an intersection point of the graphs of the two equations? Okay, so to solve this is a nonlinear system of equations, so you probably want to use the substitution method. All right, and they conveniently, maybe coincidentally or not, maybe a coincidence or not, they set x is y plus 1. They already wrote this for you. So you can substitute this y plus 1 as your x up here. So it'll be y plus 1 squared minus 6 times y plus 1 plus 11 is equal to y. Notice my parentheses. All right, those are important. Now let's expand this out. Y squared plus 2y plus 1 minus 6y minus 6 plus 11 is y. Let's move everything to one side now. So y squared, that's done. And then I have plus 2y minus 6y, so that's minus 4y, and that I move this y to the other side, so that would be minus 5y. Okay, 1 minus 6, that is minus 5, plus 11, that's 6. Okay, so if I factor this, this will be y minus 3, y minus 2. So the solutions are y equals 2 or 3. So y equals 2 is one of the choices. We pick that one. Okay. Which of the following expressions is equivalent to the one above, where x is not equal to 1? So it looks like they want to combine these two fractions into one, so we need a common denominator. You can you can multiply this one by 2 on the top and 2 on the bottom, so that I would get 10 over 2 times x minus 1 plus 8 over 2 times x minus 1. Same denominator, now I can combine. It'll be 18 over 2 times x minus 1. I can simplify like that. The 2 would cancel with the 18 up top. Well, not cancel, it will reduce it to 9. Okay, so it's 9 over x minus 1. Answer is A. Okay. Moving along. Whoops, the color of my light changed. Isn't good enough. Okay, for a positive real number x, where x to the 8th equals 2, what is the value of x to the 24th power? So I need to change this x to the 8th to x to the 24th. How do I do that? Let me cube both sides. X to the 8th to the 3rd power, I multiply the two powers. That'll be x to the 24th equals what's 2 cubed? That's 8. Which of the following is an equivalent form for a cube root of f to the 6a k squared? F is greater than 0, k is greater than 0. Okay, so let me change this radical into an exponent. You don't need to do this, but I'm more comfortable with exponents. All right. Now I can distribute this power into both. It'll be f to the 6a over 3, k to the 2/3, which is equal to, maybe put equal sign up there also, equals f to the 2a, k to the 2/3. Answer is D. Okay. The number of people who go to a public swimming pool can be modeled by the function g above, where c is the constant and t is the air temperature in degrees Fahrenheit for t between 70 and 100. If 350 people are predicted to go to the pool when the temperature is 90 degrees Fahrenheit, what is the value of c? Okay, so again, lots of words. You got to pick out the key information. This is modeling the situation. So what values do they give us? 350 people are predicted to go. So 350, which variable does that go to? G is the number of people, right there. So you would set 350 as your G. Okay, so what's next? T, the temperature, the air temperature. T is 90 degrees, so it'll be 5 times 7 times 90 minus, we're trying to solve for C, over 2 minus 25. Okay? So be careful, you gotta add the 25 first on both sides, or technically you can multiply by 2 on both sides, but you have to multiply the whole thing. There's a common mistake where you just multiply it to this. That's not right. So let's add the 25 first. 375 would be 5 times, that's 630 minus 12c over 2. So now let's multiply by 2 on both sides. This would be 750 is 5 times 630 minus 12c. By the way, you're not allowed a calculator. I think I said that earlier, so you got to be able to do this math. Either you write it out or you do it in your head. Okay? Divide by 5. What is that? That is 12. That's not right. 120 would be 630 minus 12c. So 12c is equal to, this doesn't look right, actually. Let me check this one more time. I think this is wrong. That is, 150 here. Sorry about that. So 12c is, now I move this side over there. That is 480. So c would be 4d. Okay? Answer is B. I was able to tell right away because these are all nice numbers. 120, that would be 510. That's not divisible by 12 into like one of these. That's how I was able to tell right away that I made a mistake. Okay, moving on. The boiling point of water at sea level is 212 degrees Fahrenheit. For every increase of 1,000 feet above sea level, the boiling point of water drops approximately 1.84 degrees Fahrenheit, which the following equations gives the approximate boiling point B in degrees Fahrenheit at h feet above sea level. So you're taking the situation and now you're modeling it. So it's the inverse of the previous problem where we use the model. Here you're going to create the model. Okay, so let's keep things easy first. At sea level, that means h equals 0, no height. At sea level, the boiling point is 212 degrees. So your model should reflect that. So when h is 0, B is 212, B is 212, B is 212. Here, when h is 0, B is not 212. So you can eliminate that right away. Okay? This one, okay, so first of all, the boiling point is decreasing as you increase in elevation, in height. Okay? So that means, for example, if you go, if you go 1,000 feet, then it drops by about 2 degrees. So just round up and imagine it's 210 degrees. Okay? So when you go up 1,000 feet, this one, the boiling point actually increases. So for sure, it's not that. Okay, now which one is it? It's actually B. You got to be careful with the unit. Okay, so you could just use my example that I just did. When it's 1,000 feet, h is in feet. When you increase by 1,000 feet, it should only drop by 1.84. If you plug in h is 1,000 here, you're moving this 3 times, you're going to subtract 1840. That's for sure not right. This one would be the right one. Okay, if you didn't want to do it like this, going choice by choice, the quicker way is, well, I know that this has to be the slope. This is the slope of the linear line, and this is the y-intercept. Okay, because when h is 0, y is this, or your b. B and y is the same thing. In this case, is the dependent variable. Okay, so this is the only one that has a y-intercept. These three are the only one that have a y-intercept of 212. Okay, and I was saying it should be a negative slope because the boiling point is decreasing. This is a positive slope. These two are negative slopes. Eliminate that as well. Okay, and then here it's 1.84 degrees. This is where the units can help over 1,000 feet. Okay, so that's why it's this number right there. So imagine if you plug in your 1,000 feet, the 1,000 feet would cancel and you get minus 1.84 degrees. Okay, that's another way to think about it. That's how I would have thought about it. The graph of x squared minus 4x plus y squared plus 6y minus 24 equals 0 in the xy plane is a circle. What is the radius of the circle? This is a classic completing the square problem, so let's do that. X squared minus 4x. To complete the square, you take first of all, the term in front of the squared, the a, if it's in standard form, ax squared plus bx plus c, the a has to be 1, which it is in this case. Okay, so it'll be plus, you take the whole b minus 4 over 2 squared. Okay, we got to subtract it back right? Or you can put it on the other side of the equal sign. So I'm going to do that. So it'll be, let me move this 24 also. I'm going to do a few steps in 1 plus minus 4 over 2 squared, okay? And then this is also a 1 in front, so we're good. So it'll be y squared plus 6y plus 6 over 2 squared. Again, the b over 2 squared. And then you got to add it to the other side as well in order for this equation to hold. Okay? So if we complete the square, it becomes, you just take the term on the inside, so it'll be minus 2 squared plus y plus 3 squared is what's over here. That's 24 plus, that's minus 2 squared, that is 4, that is 3 squared plus 9. Okay? So this is, by the way, this is your r squared. This is in standard form now for the circle. Okay, centered at the hk over here. Okay, so what is this over here? That is 28 plus 9, that's 37 is r squared. So your r would be square root of 37, which is c. Okay, moving on. Last few problems. This is no multiple choice, no more. Okay, value of one solution to the equation above is 1. What is the value of the other solution? So how do we solve absolute value equations? You drop the absolute value sign. You have this side, one of the solutions would be equals 4, which is the one that they had there. 5 minus x is 4. That's one of the branches. And the other solution is 5 minus x is negative 4. That's the solution that they're asking for here. So x would be 5 plus 4, which is 9. Okay. Next, f of x is x squared minus 4x plus 10, and c is a positive integer less than 5. What is one possible value of f of c? F of c. I don't know what I just said. Okay. Positive integer. You got to be careful. 0 is not positive, so you can't pick that. You can pick 1, 2, 3, or 4. Any of those work. So I'm just going to, for simplicity, pick 1. F of 1. C is positive, and it's an integer, and it's less than 5. Okay? So what's f of 1? That's 1 squared minus 4 times 1 plus 10, which is 1 minus 4 plus 10, which is minus 3 plus 7. I mean, minus 3 plus 10, which is 7. That's one possible answer. Students in the science lab are working in groups to build both a small and a large electrical circuit. A large circuit uses 4 resistors and 2 capacitors, and a small circuit uses 3 resistors and 1 capacitor. There are 100 resistors and 70 capacitors available, and each group must have enough resistors and capacitors to make one large and one small circuit. What is the maximum number of groups that could work on this lab project? Okay, so each group, they're making both a large and a small. So how many resistors total and capacitors total do they need? They need 7 resistors total and 3 capacitors total. Okay, So if there's 100 resistors and each group needs 7, how many groups can there be? So if we divide, again, you have to be able to do this in your head or write it out, okay? So this would be 1, this should be 14, it's 14 point something. So you can't have, you can only have 14 groups because that point something, you won't have enough resistors. They won't have the 7. They'll have only a fraction of it. So you take out the remainder or that decimal portion, okay? Now what about 70 over 3? How many groups can that handle? That would be 20 something. 20 something, I don't care. This can handle more groups than this. The limiting one is the resistors, so you can only have 14 groups. Okay? Angle with a measure of 7 pi over 6 radians has a measure of d degrees, where d is between 0 and 360. What's the value of d? Oh, this is very easy. What's pi over 6? Pi over 6 is 30 degrees. So 7 times 30 degrees, that is 210 degrees. So 210 is the answer. Final one. Function f is defined by f of r is r minus 4 times r plus 1 squared. If f of h minus 3 equals 0, what is one possible value of h? Okay, so you just got to plug in this as your r. Wherever there's a r, plug in h minus 3. And the f of h minus 3 is 0. So 0 is equal to, so again, wherever there's an r, plug in h minus 3. H minus 3 minus 4. H minus 3 plus 1 squared. Okay, so 0 is equal to h minus 7, h minus 2 squared. Okay, so h can be 7 or h is 2. Either one's fine. So I was just filling 7. Again, 2 is also okay. That's the acceptable solution. Okay, and that's it for the no calculator portion. Hopefully you did well. I thought this was pretty simple. No tricks at all. The only trickiest part, honestly, is you got to be able to do some of the math. This is like not a nice division. There was a remainder, but you had to be able to think that, oh, you don't care about the remainder here. Things like that. There was another one where, like this, it's a little larger numbers. You got to be able to do that. I feel like that's the hardest part for this, where a lot of errors can happen. Otherwise, the concepts were pretty straightforward, at least to me, hopefully. Well, of course, to me. I've been teaching this for many years, so hopefully it's clear to me. But anyway, if you have any further questions, feel free to leave it in the comments. Otherwise, as always, please like and subscribe if you found this helpful.